So for section 7.3, we're moving on to multivariable linear systems. So far, we've been dealing with just two variables, x and y, and now we're going to add a third variable. So the three methods that we've used on the previous couple pages to solve systems of equations. One thing we mentioned, and this is actually one we haven't used yet, but we mentioned it. You can switch any two equations. So you can rearrange the order, and this is going to come in handy more now that we have more than just two equations. You can also scale equations like we've done in the past, like we did a lot in 7.2, where we just multiplied equations by a value to cancel things out. And finally, you can add or subtract any two equations. And I'm emphasizing any two equations because they don't have to be next to each other. So these rules can be applied to a larger system of equations to produce what we're going to call a row echelon form. Now, row echelon, I'm not going to give us a definition for this. So it's ROW hyphen ECHELON form. We're going to demonstrate what this looks like with this next example. So we got three linear equations with three variables. What we're going to do, the first thing is we're going to identify each of these equations by a name. So this top one, I'm going to say that's called row 1. So I'm going to do R1, R with the subscript of 1. Second, we're going to do R sub 2. Let me zoom in. Third one, we'll do R sub 3. So our goal is to kind of like slowly pick away at these equations. Now, what I'm going to do is I'm already missing a Z in the second one, but I'm going to see if I can eliminate the X in rows 1 and 2. So if we take row 1 plus row 2, and I'm going to do this off to the side here, we got x minus 2y plus 3z equals 9, and add it to negative x plus 3y, there's no z, so I'm just going to leave that spot blank, equals negative 4. When we add these together, we have, well, the x's cancel out, we have negative 2y plus 3y, that gives us positive 1y, and then we have 3z plus, well, if it helps you to put it as, and maybe I'll write this in a different color, it might help you to think about it as 0z. So 3z plus 0z is 3z. Let me switch back to that color, sorry. We got plus 3z, and then finally 9 plus negative 4 gives us 5. So what we can do now is replace that with, or replace the second line with that equation. So now we have the form, or the system. We're going to leave that top row alone. We got x minus 2y plus 3z equals 9. The second one, we're going to replace that with what we just found. We got y plus 3z equals 5. And we haven't done anything with the third row yet, so 2x minus 5y plus 5z equals 17 still. So essentially now we have x, y, and z in the first row. Then in the second row, we just have y and z. The third row, ideally, we're going to get it down to just z. So what we're going to have to do is we're going to have to combine some of the rows in one way, shape, or form by adding, subtracting, switching them around. What I'm going to say we can do here is let's see if we can get rid of that x, because eventually we want it down to be just z. In order to get rid of that x, what I'm going to do is I'm going to take negative 2 times row 1. We're going to take the entire row 1, multiply by negative 2, and then add it to row 3. So that way we can cancel out the x's. So jotting that down, if we do negative 2 times row 1, so again, we're multiplying this whole row by negative 2. We got negative 2x, multiplying negative 2y times negative 2, that gives us plus 4y. Then 3z times negative 2 is negative 6z, and then 9 times negative 2 is negative 18. And we're going to add that to row 3. We're going to add that 2x minus 5y plus 5z equals 17. And we're going to add those two rows together, and the x's cancel out. That's the whole point. We have 4y plus negative 5y. That gives us negative 1y, or just negative y. We have negative 6z plus 5z, and that's going to give us negative 1z, so just negative z. And then negative 18 plus 17, that's going to give us negative 1. So now we can replace that third row with that. So let me just rewrite this here. We got first row still x minus 2y plus 3z equals 9. Second row, we did that earlier. We got y plus 3z equals 5. And now our final row, we eliminated the x's. So now we have negative y minus z equals negative 1. Awesome. So now we have fewer variables in that third row. The last thing we can do is we're going to combine somehow rows 2 and 3 to get rid of the y value, so it's just down to z. So what we can do with this is if we add rows 2 plus row 3, we get y plus 3z equals 5. That's row 2. And then row 3, we have negative y minus z equals negative 1. When we add those together, the y's cancel out. The 3z plus negative z is 2z. And then 5 plus negative 1 gives us 4. So again, we added those two rows together. Now, we got 2z equals 4, but if we wanted to make it 1z, we would just get z equals 2. So now, finally, we have x minus 2y plus 3z equals 9. That first row never changed. The second row, we got y plus 3z equals 5. And finally, our last row, we have just z equals 2. This, my friends, is called row echelon form. This is row echelon form. You'll see we already have all this work down here. What it does is it has one equation solved for one variable, another equation solved for two variables, and another equation solved for all three variables. So what we can do is start plugging things back in. So like this z equals 2, we'll just plug it in for that z. So we got y plus 3 times that 2 equals 5. When we clean that up, we got y plus 6 equals 5. To solve for that, we subtract 6 from both sides, and we end up with y equals negative 1. So now we know another value. We know z equals 2. We already found that using row echelon form. And we found y equals negative 1. So now to figure out what x is, we're going to plug it into the top equation. So we're going to plug in the 2 for z and negative 1 for y. So we got x, we don't know that yet, minus 2 times our y value we just found was negative 1, plus 3 times that 2 for the z value that we already found, equals 9. Cleaning this up, we got x minus 2 times negative 1, that ends up being plus 2, and we also have plus 6 equals 9. Combining those terms, we got x plus 8 equals 9. To solve for x, we're going to subtract 8 from both sides, and we end up with x equals 1. Now, we've got all three variables solved now, so we're going to put this as a coordinate triple. We're going to say the x value is 1, the y value we found was negative 1, and the z value we found was 2. So this is obviously a little bit more work than what we did with two variables, but when you add more variables, you're probably going to add more work.